Let us solve this problem. In this problem, a potential field V is given. So we have to verify whether del square V is equal to 0 or not. And of course, we have to find A and B in the expression of V for given values of V and E. This problem is in spherical coordinate system because the variable is theta. Theta appears only in spherical coordinate system. So first, let us start. To verify del square V, okay, consider del square V. In spherical coordinate system, its expansion is 1 by r square, dou by dou r square into dou V by dou r, plus the second term is 1 by r square sine theta, dou by dou theta, sine theta into dou V by dou theta. The last term is 1 by r square sine square theta, dou square V by dou phi square. In this problem, if you observe V, only theta is there. So V is a function of only theta. V is a function of theta only. So dou V by dou r 0. Dou V by dou phi is also 0. So del square V now becomes 1 by r square sine theta d by d theta of sine theta into dv by d theta. Since there is only one variable theta, no partial derivative is required. 1 by r square sine theta d by d theta sine theta, differentiation of V. So let us substitute V here. That is A ln of tan square theta by 2 plus B. This is RB. One more bracket required. Now we have to verify whether del square V is 0 or not. So for that, you should start simplifying. Let us perform the differentiation first. So del square V is equal to 1 by r square sine theta d by d theta. Let me have a flower bracket sine theta. So the differentiation. A constant. Differentiation of ln natural log is 1 by the term. The term is tan square theta by 2. So natural logarithm is differentiated. The argument of the natural log is tan square theta by 2. That is to be differentiated. Differentiation of tan square theta by 2 is 2 tan theta by 2. So ln is differentiated, then tan square theta is differentiated. That means the power is differentiated square. Now we have to differentiate tan theta, that is secant square theta by 2. So after differentiating tan theta, we have to differentiate theta by 2. Differentiation of theta by 2 is 1 by 2. So this completes the differentiation because differentiation of b is 0 with respect to theta. It's a constant. So the next step should go for simplification. R square sine theta d by d theta of sine theta into a. Here what happens? One tan theta goes with the square. Tan theta by 2 goes with tan square theta. And also the 2 and 2 are cancelled. So we are left with the secant square theta by 2 divided by tan theta by 2. The rest are all cancelled. The next del square v is equal to 1 by r square sine theta. Before differentiation, we can simplify this further. Sine theta into a. Secant square theta by 2 can be written as 1 by cos square theta by 2. One by cos square theta by 2. Tan theta by 2 is sine by cos. So it's 1 by tan is cos by sine. So cos of theta by 2 by sine of theta by 2. See here one cos cancelled with this flow. So 1 by r square sine theta d by d theta of, here what happens, a sine theta, let it be as it is. So in the denominator we are left with sine theta by 2 into cos theta by 2 after cancellation. Sine theta by 2 and cos theta by 2 can be combined with the formula sin 2 theta is equal to 2 sine theta into cos theta. But in this case, instead of theta, we have theta by 2. So if you modify the formula for sine theta by 2 and cos theta by 2, we can write left side as theta. So if you take this to this side as 1 by 2, then we get the product sin theta by 2 cos theta by 2. So therefore, the next step, our del square v becomes 1 by r square sine theta, differentiation of a sine theta divided by, so in the denominator, the product becomes sine theta divided by 2. So now sine theta is cancelled over here. So we are left with differentiation of 2a. 2a is a constant, therefore the differentiation of 2a is 0. Finally, del square v is equal to 0. So we approved it. Hence the proof. So proof is over. Then the next step, we have to find A and B. Part 2. Part 2 demands the calculation of A and B for the two given values. One is V equal to 100 volts and another one magnitude of E equal to 500 volts per meter. But at some point P, which is given, let us check what the point is from the problem. It is 5, 60 degree, 45 degree. At the point 5, 60 degrees and 45 degrees. And here 5 is your R, 60 degree theta, 45 degrees phi. Using this data, let us find A and B. In this one, let us take first part. Let us make use of the value of V, which is 100 volts at this point. So we have an equation for V given in the problem itself. A ln of tan square theta by 2 plus B. So V is given in the numerical itself. So now we can substitute V 100. Before using this value of 100, we have to substitute this value of point P into this equation. So that is A ln of tan square theta. What is the theta value? 60 degree divided by 2 becomes 30 degree plus B. So 100 is equal to, so the ln of tan square 30 is given by minus 1.0986 plus B. So this value can be rounded off to minus 1.18 plus B if needed. If you want to proceed with the exact value, no problem, that is appreciated. Let us call this equation as number 1. Then you will make use of another value, that is 500 anyhow, that is 500 for E. So first we have to find E, negative gradient of potential. E is minus dou V by dou R, 1 by R, dou V by dou theta, A theta, theta component, minus 1 by R sin theta, dou V by dou phi, A phi, the phi component. And we know that from the equation here itself, V depends only on theta. So dou V by dou R 0, dou V by dou phi also 0. So E is given by 1 by R dV by d theta. So now let us find E, that is d by d theta. So in place of V, we shall write A log of tan square theta by 2 plus B. So theta component. We're already familiar about this kind of differentiation. Now A is constant. Differentiation of log is 1 by tan square theta by 2 into differentiation of tan square is 2 tan theta by 2 into differentiation of tan is secant square theta by 2 into differentiation of theta by 2 is 1 by 2 into differentiation of theta is 1. So completely every term is differentiated. Differentiation of B is 0. So we are left with A cap theta. Now the simplification gives us, as we all know, tan term is cancelled. This fellow 2 is cancelled here. Then we are left with A, as usual, secant square theta by 2 divided by tan theta by 2. A is there, one tan in the denominator and secant square is there, into A cap theta minus 1 by R. A secant square is 1 by cos square, we know that, into 1 by tan is cos by sine, A cap theta. You know what happens here, right? When cos term cancelled, denominator is sine theta by 2 into cos theta by 2. So that can be directly written as 2 by sine theta. That can be written directly cos theta by 2 and sine theta by 2. Sine theta by 2 and cos theta by 2 is sine theta by 2. That takes the value into the unit vector. This is what is our E. But for the problem, what is required is modulus of E, whose value is given, that is given by A by R, 2 by sine theta. Modulus is always positive. Magnitude of unit vector is 1. Now we have a point. At point P, that is 5, 60 degree and 45 degree, we can find the electric field at point P. What is the E value given in the problem? It's 500 volts per meter. So 500 is equal to constant A, R value of 5, 2 divided by sine of 60 degree. So after solving, we get A value as 1082.5. So A is ready. To find B, we have an equation number 1, that is 100 equal to minus 1.1 A plus B. You can write that as from equation 1, From equation 1, we have 100 equal to minus 1.1 a plus b. From this relation, we can find b. So 100 is equal to minus 1.1. A is 1082.5 plus b. So b can be calculated as 1290.75. If you use exact value for this 1.1, some of you may also get the answer as 1288.6. This is also right. Both are approximately equal. This small error occurs due to rounding of the values. So that is the problem. Thank you.